Welcome back. In last few videos, is what we discussed. Under unit number 1, we discussed basic concept: force, resolution of force, moment of force, and that we apply to find out resultant. In unit number 2, FBD, friction, we obtain unknown reactive forces. In beam and trusses, we find out unknown reactions at support. In trusses, a force develops in member of a trusses. Now, next topic under mechanics is a centroid and moment of inertia. Moment of inertia you people studied, but that is a mass moment of inertia and center of gravity. In engineering, we never take a body. We take a body as a plane figure, weightless lamina. And therefore, it becomes necessary to discuss centroid and moment of inertia. This is a new unit. From this video, we are going to discuss this centroid and moment of inertia, which is a most important topic of engineering. Second year, third year, whenever you are going to design anything, from building column to design a car, yes, you have to find out whenever you are going to just design any structure, anything, yes, of that shape, you have to find out moment of inertia. Some computer site student going to design software for such structure, yes, at that time you have to understood this moment of inertia also. So, most important moment of inertia and center of gravity that you have to use throughout your engineering study. So, what is that? So, for that I am going to start with term center of gravity. So, center of gravity is applicable to a body having weight, and we define that as it is a point. Center of gravity is a point through which entire weight of that body, assumed to be act for all position of that body, whether we kept body horizontally, vertically, inclined, even though its weight acts vertically downward through a point, that is called as center of gravity, applicable to body having a weight. As we know that a sphere is a body, but circle is a plane figure, and everybody knows every circle got a center, and center of such plane figure is called as centroid. That we need in engineering. We have determined centroid. So what is centroid? It is a point through which entire area of plane figure like rectangle, triangle, circle, semicircle, sector assumed to be act for all position of that plane figure. It is a point through which entire area of plane figure assumed to be act for all position of that plane figure. In other words, center of area called as centroid. And this topic, centroid and moment of inertia, we are going to start with derivations of centroid of basic shapes: rectangle, triangle and semicircle. But for deriving that derivation, we required one formula. Just for derivation, we need that formula. They never ask in exam that derivation of that formula. As for derivation of rectangles, triangles, semicircle, we need a formula. As that formula, let's clear it. So for that purpose, as we have this as any area in xy plane, and this is a centroid of that area. That area may be rectangle, maybe triangle, maybe semicircle, and that is in xy plane. And we have to locate the centroid of this plane figure. So we have to measure that distance from x axis. As from x we measure distance this much, which is vertical, and therefore as y bar is its notation. Vertical, therefore y bar. And distance of centroid from y axis horizontal, therefore x bar. So y bar, a centroidal distance of plane figure from which axis? Y bar, opposite x axis. And x bar, centroid distance of plane figure from y axis. So for that we require a formula. Okay. So for every derivation we are going to consider one element. Element means very small figure. So that element dA. dA is an element. And whose centroid is here at distance y from x axis and x from y axis. And for that, okay, nobody asked in exam, just in next derivation we require this formula. Therefore I am going to explain here. Y bar formula is integration y dA by A, and x bar formula integration x dA by A. Getting everyone? And remember, while deriving expression of parallel axis theorem, we need this formula again. What do you have to remember? Y bar and y measured from same axis. Y bar y measured from same axis. Similarly, x bar and x measured also from same axis. Okay. So this is a start. Just we start a centroid. Okay. And we discuss centroid of common geometrical figures, a formula. Next video we are going to discuss is we are going to derive formula for centroid of rectangle.